Assalamualaikum and good morning everyone. Today we are going to present our project part 1, which is CPU and hardware performance benchmarks. Okay, so next. Okay, this is our teammate, which is me, is NURIN HAZWANI binti HUSSIN, and then my friends is ELISA AFIRA binti MOHAMMAD NAZIR and BALQIS binti MOHAMMAD SARMIZI. Okay, the introduction. Benchmarking a CPU is essential to evaluate and understand the real-world performance of computer system under different workloads. Okay, in this project, we explore hardware benchmarking using free tools assess CPU and this performance. Additionally, we implement an assembly program to simulate mathematical operation and observe processing type under repeated loops. Okay. Kan nak semula. Okay. Next is our introduction, which is benchmarking is essential to evaluate real-world performance of computer systems. In this project, we use freeware tools and our own assembly code to assess CPU and storage capability across 3 laptops. Okay, next is our objective. Our objective includes understanding CPU benchmarking and its impacts on performance, and then using tools like CPU Z, Geekbench, Task Manager, and Mini2. And then we are comparing different laptops under various workloads, simulating CPU loads using assembly, and then enhancing skills in analysis, reporting, and teamwork. Okay. Next is purpose of project. Okay, we aim to find the best laptop for students, one that balances performance and affordability. By testing performance and price, we want to recommend the most practical device for academic use. Next slide is scope. The scope of project, we benchmark 3 laptops, which is Victor's HP 16, and the price is 3,699. And then the second laptop is Acer Predator Helios Neo 16, which is the price is 6,999. And the third laptop is Acer Aspire A315-35, which is the price is 1,899. Okay, the test is included CPU, GPU performance, disk speeds, task manager loop behavior, and ASM loop execution timing. In this table, we already have the price, and then the CPU, and then the GPU, which is these two have a 2 GPU in the computer, but the different price and different GPU. Okay, next is methodology, which is we have flowchart of benchmark. We follow a structured flow starting from system info collection to this benchmarking and LSM testing. And then we included what benchmarking software that we use. Okay, so next is the flowchart. Okay, the first one, we start from set up 3 different laptops for testing. And then we install 4 selected benchmarking tools on each device. And we ensure that when Windows OS and device drivers are fully updated. So next step is adjust system power setting to high performance mode, and then we restart all device to apply setting clearly, and then we begin the benchmarking test using all 4 tools, and we record the benchmarking result for each test session, and we repeat all benchmarking for different laptop. And lastly, we evaluate and compare the data collected for accuracy and performance inside. So next is the benchmarking software that we use, which is CPU Z, Geekbench, Monitor, Task Manager, Windows OS 2, which is that we have, and then the last one is Mini2 Partition Wizard, which is this benchmark.
Assalamualaikum and hi, my name is BALQIS binti MOHAMMAD SARMIZI. So today I will demonstrate how to benchmark. So first, I will open the CPU Z tools. So for my CPU, the name is Intel Celeron. So when we use CPU Z tools, It will show the information about our processor, our CPU, our main board, memory, graphics, and all. So for the CPU, it will show the name, the code name, like your gen, and then the clock's core speed. So that's all from the CPU Z. Next, we will use the mini tool partition wizard to test this benchmark. So first I will do the sequential mode. So let's start. It will take a bit of time to test this, so we will wait. So the highest sequential reading and writing is at 32 kilobyte. It's 1117.85 for sequential reading. For sequential writing, 224.613. So let's try other modes, which is random. Okay, so for random mode, the highest random reading at 32 kilobyte is 776.132. Random writing 185.267. So this is for the mini tool partition wizard tools, and the next tools is task manager, which we have like window provide for our laptop. You can just open the task manager and you can press on processes and you can see the memory here. So since I open like Webex, Microsoft Edge, the tools, so the memory, it takes a lot of the memory space. So now it's 85%, and it will keep on rising or decreasing based on the apps that we open. So this is the memory right now and the performance like graph, I think. So the graph is like this, and then this is our GPU, our CPU is like 100%. Okay, then let's move to the last tools, which is Geekbench. For Geekbench, it takes a lot of time to wait, so I will just show the result for my laptops. So my laptop is expire 131535. So the single core performance score, we got 318. For the multi-core, we got 661. So it will show all the things that happen in the laptops here. It will also show the information about our CPU, which my CPU name is Intel Celeron N4500. The frequency 2691 MHz, and the size of my memory is 4 GB. So that's all from me. Thank you.
Next is the screenshot of tests that we conduct. We have 3 laptops, so we evaluate 3 of them. Okay, this one is CPU Z, which that you have already know. This is for computer 1, which is the Victus, and it has a processor which is AMD Ryzen 5. And then the benchmarking is quite low from the computer 2, which the computer 2 have 8 gig, and then the computer 1 is 6 gig. And then this is the third computer, which is quite low for the benchmarking. And then we proceed to the second one, which is Geekbench. This is Geekbench for computer 1, the single core performance and multi-core performance. And then this is the CPU information, which is same, the CPU information. And this is the single core performance and the multi-core performance, which is this is quite high. Okay, then this is the computer 2, which is the single core performance is quite low, and then the multi-core performance is quite high, and this is their CPU information. Next is computer 3, the single core performance and multi-core performance, and then the CPU information. This Geekbench is for the stress test at the single core and multi-core performance, okay, for different laptops. And then next is monitor task manager for different load, which is this one is low load, medium load, and high load for computer 1. And then next is for computer 2, which is we have low load, medium load, high load that we expected already. And then we have, this is the computer 3, low load and medium load and high load. Low load is between 30 and 50%, medium load which is 50% to 60%, and high load is bigger than 70%. Okay, next is this benchmark, which is the test mode is sequential and random. This is for the computer 1, which is quite high for the sequential and random. And then we have the computer 2 for sequential and random, which is it including for writing and reading. Okay, and then this is the third sequential and random result for computer 3. And then we move to the result of all of it. And then this is the CPU performance that we have, the information, which is the specification for generation, clock speed, number of cores, which is the computer 1 have hexa core, which is 6, and then computer 2 have 24, computer 3 have dual core, which is 2. And then this is the generation that we had, and the clock speed, which is the computer 1 is higher clock speed than anyone else at there. Okay, next is GPU performance. The GPU performance have a specification, which is core speed, memory speed, maximum amount of memory, and memory bus width. For the first computer, we have 2010 to 2355 megahertz, and then the second one is 1605 to 1980. The third one is 350 to 750, which is quite low. And the core speed between these three is computer 1 is the highest one. And then the memory speed is same between the two, and the difference for computer 3, which is 2666. And then the maximum amount of memory, which is computer 2 is the highest, which is 8000 MB, which is 8 GB. And then the memory bus width in bit, the second computer is the highest, which is 128. Okay, this is the result of all of that we already included from the earliest task, which is this one is the Geekbench CPU stress test that we already do it, and this is the result, and we already concluded all. Okay, vectors show the grid balance, and predator leads in the storage, like I said. Aspire is only suitable for basic tasks. Okay, in this slide, vectors show grid balance. Predator leads at storage, that I said, and Aspire is only suitable for basic tasks. Predator Helios has the most core, which is 24, best for multitasking, and Vectors has a higher clock speed and better single core performance. Okay, so next is discussion of the result, which is the order of laptop in terms of CPU and GPU performance. For CPU performance, Acer Predator lead the way, which is it number 1, and then Victus, and then Aspire. For GPU performance, it's also same. For Acer Predator is lead, and then Victus HP16 and Acer Aspire. Overall, Acer Predator Helix Neo 16 is the powerful, but it's a bit pricey for student, which is the price is almost like 7k, and then Victus give a great value, which is only like 3006, and then it much better. And because we are a student and we don't have that much money, and then Aspire is only for the light tasks. Next is conclusion and reflection for all. Okay, based on this slide, benchmarking plays an important role for both user and developer, as it provides an independent and objective perspective on hardware performance under specific condition. And benchmarking reveals the weakness and limitations of their hardware products. This insight allows them to make improvement and create devices that perform better and meet user needs. We compared and understood how specifications like core speed, memory amount, and memory bus width affect performance. It's giving consumers the chance of test hardware performance themselves. So rather than just trusting marketing claims, does protects consumer from being misled by exaggerated ads. So next is project part 2, which is writing ASM code program for benchmarking software, and it will be present on assembly language, which is that we coding and the equation used, and then we already made it, and I will pass to my other team to present it. Thank you.
Welcome to Project 2 CPU benchmarking using assembly language. So we develop our own assembly program to simulate CPU load using mathematical equation. So the equation that we use is y equal to 14x power of 3 plus 3x power of 2 plus 9x plus 25. The coefficient 14, 3, and 9 were derived from the birthday of our members, while 25 is the random number. So according to the code, the user will enter a loop count, which is n, and then the program will calculate y in a loop for each x from 1 to n, and the leaves are added to simulate processing time. We use get m second to measure the start and the end time, and then display the total time taken. So let's take a look. First, rebuild the solution. As you can see, it's succeeded, so we proceed with debugging. Okay, here the user will enter the loop. For example, let's say 50. And the program will calculate the value of y, adds the delay per coefficient, and finally display the time before and after the loop along with the thumb result. So here is the example of showing CPU execution time in milliseconds and the total sum of computed values, as you can see. So let's go with y, and let's say 100 is time. So as you can see, this method let us stress the CPU with a custom load and measure performance using our own low-level logic. That means different computer will bring different results. So let's take a look at the Canva. So here is the result for computer 1, which is the Victus. So this is mine, the result for mine. As you can see, it's different in value. And the last one is computer 3. So that's all from me. Thank you.
Okay, my personal reflection throughout this benchmarking project, I had the opportunity to deepen my understanding of computer hardware, especially CPU and GPU performance. One of my main tasks was to analyze CPU benchmarking using freeware tools like CPU-Z, Geekbench, test performance manager, and mini-tool partition wizard. By doing this, I learned how different specs like clock speed, core count, and cache size directly impact system performance. Additionally, I challenged myself by writing an assembly language program to test loop execution time. At first, it was quite difficult because I didn't have much experience with assembly, because we only have lab 1, lab 2, and lab 3 at our course. And then but after researching tutorials and experimenting with code, I managed to simulate CPU load effectively. Okay, then another task that I took on was designing the flowchart using draw.io and preparing the presentation slides. This task helped me improve my communication and documentation skills, especially in organizing technical information in a visual and professional format. Most importantly, this project taught me the importance of teamwork. We had to divide tasks fairly and constantly update each other to make sure everything was aligned. And then working with BALQIS and ELISA also helped me practice active collaboration and time management, especially when juggling with multiple responsibilities. Okay, in conclusion, this project gave me a well-rounded experience in both technical and soft skill. And then I now feel more confident in benchmarking, system analysis, and writing assembly code, and presented technically finding clearly. It was a very valuable experience, and I believe it has prepared me well for future group projects and my final year research.
So my reflection through this project, we learned a lot about the importance of testing and analyzing computer hardware like CPU and GPU. We also discover how to use software tools such as CPU-Z, Geekbench to measure the performance of our CPU. Although we faced some challenges throughout this project, we managed to solve them together as a group. And overall, this project gave us a useful knowledge that we can use and benefit us in our studies and future careers. Thank you.
So for reflection, I think our benchmarking project gave us hands-on experience with evaluating hardware performance in real-world scenarios. We also learned how to use tools like CPU-Z, Geekbench, and Mini-tool partition wizard to get accurate CPU, GPU, and disk performance data. A key insight was discovering that specification doesn't always tell the full story. For example, my laptop, despite its high-end CPU and GPU spec, showed lower CPU benchmark score than expected. It is possibly due to thermal throttling or power management. Um, I also think that this project helped us develop teamwork and communication skill. As everyone contribute to testing, coding, and reporting, we also improve our ability to interpret technical data and present it clearly. Overall, the experience deepened our understanding of benchmarking importance for both user and developer and prepare us well for future technical projects. So that's all from me.